Alright, so hello again. Parang nabawasan kayo. How many are we a while ago on part 2? I think we were 10 or 11. Okay, so let me just check if you guys are already in front of your computer. So just give me a thumbs up. Alright, great. So I guess the others won't be joining us anymore. Okay, so are you guys ready now for this example? Oops. Meeting. Alright, so let's answer this example right here, wherein we have Vi is equal to 20 volts and then Vr is negative 5 volts. Okay, so in here we'll start with positive half cycle because we wanted to make this one forward bias as usual. And during the positive half cycle, and this one is this one again, 5 volts, 5 volts. Okay, so in here during the forward bias or during the positive half cycle, this will become a forward bias, okay, for this VI right here. And then at the same time, this is also a forward bias for this VR right here. Okay, since negative is connected to negative and then positive is connected to the positive. So again, in here, this will be positively charged by VI and then it will be negatively discharged by the VI also. So as a result, we have here a negative 20 volts. So the same with this one, this will be negatively charged by this VR and then it will be positively discharged by this VR. We have this flow of current right here. Okay, so we have here negative 5 if we are going to read this one clockwise. So negative 5 plus negative 20 is equal to negative 25 volts. So that is now the value of our VMC. Okay, so VO right here is equal to negative VR, and then VMC right here is equal to negative 25. So negative VR is negative 5. And then during the negative half cycle, so this capacitor now will be discharged. That is because this diode will become a reverse bias. So if that is the case, so we can just simply use this formula. PO is equal to PI plus VMC. Okay, so negative half cycle. So we have here negative 20 plus VMC is equal to negative 25. So VO is equal to negative 45 volts. Okay, and if we are going to compare this one, we have the same result. So give you guys 10 seconds, maybe 10 to 20 seconds to analyze everything. And then once you guys are already okay with this one, you guys have already fully understand everything, then just give me a thumbs up so we can now proceed to the next example. Okay, so there is one who is not maybe around. Anyway, so tapos na pala tayo then. So we now only have one last example. But before that, here are the applications of clampers. So this one is used as direct current restores. This one is used to remove distortions, used as voltage multipliers, used for the protection of amplifiers, used as test equipment, and then used as baseline stabilizer. Okay, and let's now proceed to the this tau. Okay, discharging time and then discharging time that I keep on talking a while ago. So we have two parts right here, the charging time of capacitor and then the discharging time of the capacitor. So for the charging time, so it's being represented by tau and then capacitance. So like TC, charging. So you can actually call this one charging for DC, and then T for time. So charging time of the capacitor is equal to 5 times resistance times this frequency right here, and then times the, my bad, RF pala to magkasama. Okay. Forward resistance pala to. I forgot to mention that forward resistance is equal to RB. Okay, so they are just the same. So RF is equal to forward resistance, or RB is equal to bulk resistance. So this RF right here, or forward resistance, can be found on our diodes. So again, in our examples in here, we only have first approximation and then second approximation. Well, in here, actually, it's purely first approximation since all of them are ideal. And we haven't solved any non-ideal. So yun na yung magiging hint nyo, maybe. So hopefully, second approximation and then third approximation lang yung magiging quizzes nyo. So yun yung mga pwede nyong i-expect for your quiz and then for your exam. Okay, so there will be a value of this diode, let's say voltage threshold, and then at the same time, there is now a forward resistance or a bulk resistance. Okay, so RF right here is the forward resistance, and then C is for the capacitance. Okay, so this DC right here is the time period to charge the capacitor in seconds. Okay, and then for the discharging time, so D for discharging and then T for time. So you can read that one as it is, discharging time is equal to 5 times RLC. Okay, R for the resistance, and then L, ito na naman tayo. Kala ko inductor to. Okay, so magkasama pala ulit to. My bad. Okay, so RL, so which is the load resistor or load resistance. So RL is this one, and then C for the capacitance. Okay, so I should have put a bracket na lang dito or multiplication para hindi confusing na this one is resistance and this one is inductance. Anyway, so TD is for the time period of to discharge the capacitor in seconds. And then RL, alam niyo yan. And then C, you also know this one. So let's have an actual example. So this one is a negative clamper with bias and charging and discharging time. So this one is the positive bias. So in here, we still need to solve, the VO and then the VM and then what is the output in negative. So lahat pa rin. It's just that there is an additional one which is calculate the charging and discharging time of the circuit. Okay, so nadagdagan lang ng charging and discharging time. So you can just simply use these formulas right here. Anyway, so in here we have consider the RF, which is equal to 0. So we don't have bulk resistance. And then the V peak, okay, or the VI is 15 volts, okay, during the positive half cycle. And then negative 5 during the negative half cycle. So ito na naman yung isa sa mga twist. So that doesn't mean that if you have a 15 volts input, okay, for the positive, you will also have a negative 15 volts for the negative half cycle. So we can also control that one wherein during the positive half cycle, we only have 15 volts. And then during the negative half cycle, we only have negative 5. Okay. So in here, of course, we will start. Kunin ko na lang lahat para ma-drawingan ko. Okay, so in here, of course, we will start with positive cycle since that is what we wanted. We wanted to make this one a forward bias. Okay, and in here, it's very obvious of whatever is the value of your C1. So C1 is equal to VI minus VR, since it will pass through this V2 right here once VI is greater than VR. Since once VI is greater than VR, then this will become now a forward bias. Okay, even though initially uh, positive, I mean initially mas mataas to, pero magiging reverse bias pa rin siya kasi nga positive is connected to negative and the negative is connected to positive. Okay, so the capacitance value right here will be positive VI minus this value right here, this VR. So VI is 15 volts for the positive half cycle, and then minus 5 is equal to 10 volts. Okay, or negative 10 volts, since kabaliktaran nga, it will be positively charged and then it will be negatively discharged. Okay, so that's it for the positive half cycle. And then for the reading of VO, of course, it would be VO is equal to your VR, okay, or this V2 right here. Okay, so yeah, that's why we have positive 5 volts in here. So were you guys able to get the positive half cycle? Okay, and during the negative half cycle, so we now only have 5 volts. Okay, and we can just simply use the formula VO is equal to VI plus VMC. Ito na yun. Lagi naman ganyan sa pangalawa. Okay, so there is no changes. So VI is equal to negative 5, of course, since we are now in negative half cycle. And VMC is equal to negative 10 volts. So VO is equal to negative 15 volts. See? So there you go. Okay, and then for the charging time, so all you need to do is use this formula, and RF is 0, or forward resistance is 0. So any number that's multiplied to 0 will be equal to 0. So charging time is 0 seconds. So what does it mean? So as soon as there is a voltage or a current that is flowing here, it will be charged in no time. But in reality, pwede nating sabihin nanosecond. Okay? Or yung ano pa ba mas maliit sa nanosecond? So sobrang bilis lang, kumbaga. Like instant. Okay? So meron pa ring delay kasi dadaloy pa rin yung kuryente from wire to wire. Okay? It's just that maybe super fast, so that is why this one is 0 second. Okay, like you can simply neglect that one. And then for the discharging time, so we can just use this formula, 5 times RL times C. So 5 times 10K, okay, this is the R load, 10K, and then 1 microamps for this capacitance. And then just use your calculator. 5 times 10K times micro, 1 micro is equal to 50 milliseconds. Okay, so in here, seconds yung magiging sagot nyo. Okay, so dito, kung seconds to, this one is equal to 0.005 second. Okay. 1, 2, 3. So, were you guys able to, masyadong maliit. Anyway. Yeah. So, were you guys able to get this one? .05. Teka lang. 1, 2, 3. Ayaw nga. Kasi yung sa akin is 5 milliseconds lang. So this one is 0.05 second. So thank you for that one. Formula nung conversion. Kapag milli, laging, kasi 1,000 millisecond is equal to 1 second. Ayun ganun. So, ito mag-adjust ka lang ng tatlo. Okay, yung kung ilan yung zero. So, from 50, 0, 1, 2, 3. So, merong isa zero dito. So, magiging 0.0, yeah, 0.05 or 0.050. Pares lang din naman yun. And then, kapag, ano pa ba, micro, may bad, milli to. And then, kapag micro, it's 1 million. Microsecond. Okay, ito yung 1 microsecond actually. Mali to. Ano ba? 1,000 millisecond is equal to 1 million microsecond. Tama. Tama. 1 million microsecond is equal to 1 second. So in here, all you need to do is move 6 times naman. So again, kung nalilito pa rin kayo, so balik lang kayo sa graph. I think bakit nandiyan ako? Google.com. Balik lang kayo sa graph ng conversion ng milli to amps. Okay, dito laging basis ko. Okay, so just check this one out. So 1,000 milliamps is equal to 1 amp. And yeah, walang micro dito. But if you want micro, so ganun din. Magiging 1 million microamps nga lang. Okay, so micro. Meron pang susunod din, nano, which is 9. So magiging 1 billion naman na yun. Though mostly, ang gamit lang naman is milli and then micro. Ayan, ito. Meron tayong nano, meron tayong micro, and then milli. And yeah, hanggang dun lang naman. Pero meron pang isa, meron pa yung at raised to negative 12. Okay, because nano is raised to negative 9, micro is raised to negative 6, and then milli is raised to negative 3. Okay. And then, ito hanggang kilo and then mega lang naman. Though, minsan ginagamit din yung giga. Okay, so this one is times 1 billion. This one is times to 1 billion million. And this one is times 1,000. Yeah, pico yata yung 12. And then femto is, I don't know anymore. I think that's a negative, raised to negative 15 for the femto. So yeah, that's pretty much it for this clumper. So any other question or clarification so far that you guys would like to ask? Na nire-require ng mga, so naka-direct message pa to. Okay, let me just read your, can you guys see this one? Kita nyo ba to?
No, sir.
Chat? Ayan na lang. Okay, so ito yung question. Ang haba kasi. So is there a specific coding language na nare-require ng mga companies na dapat may knowledge ka if you want to be accepted sa company? Or may common coding language po ba akong need na i-master if ever? I'll try to apply jobs as software developer or engineer. I'm afraid po kasi na yung minamaster yung coding language. Yeah. That is a big factor. So, nowadays, tingnan mo lang yung one. Kasi hanggang ngayon naman, kahit na old na yung Java, reliable pa rin siya. So, marami pa rin Java. So, Java is number 1. Actually, yun yung pinaka kailangan mong ma-master. Kasi once you master Java, marami kasing klase ng version ng Java. Java View, meron pang Java React, Java, maraming klase siya pero konti lang yung nabago. Okay. Parang yung pinaka-mother or yung pinaka-basis pa rin nila is yung old Java language. So, Python is one of the, paano ko ba masasabi? Parang nagustuhan. Okay? Nagustuhan ng karamihan. So, yun yung pinaka, maybe kung bakit yun yung ginagamit na, like bakit sila nag-ship sa Python, bakit sila nag-ship sa React, bakit sila nag-ship sa, actually meron na namang bago, yung Quasar, okay, Quasar View. Okay, kaka-attend ko lang ng webinar which is, I think, ang dali lang palang gamitin and then ang dami na rin parang basis. So before, I'm into website developing before. So I think sobrang dali na lang aralin ng HTML ngayon, CSS, PHP. Pero wala na sila. Okay. Meron pa rin naman, mga ilan-ilan, pero lalo na sa mga small projects. But don't waste your time anymore in studying those language. I'm not saying that you're just wasting your time, pero pwede pa rin naman. Kaso nga lang hindi na sila ginagamit. Like when it comes to websites, Python, actually lahat-lahat na covered na ng Python. Okay, so Python is one of the best language right now. Okay, so, though it is called high level language in Python. So, yeah, depende sa generation. Maybe after 10 years from now, mag-iiba na naman for sure. 5 years from now. Kasi before, wala namang Python sa amin dati. So, hindi pa siya sikat. Though matagal na siyang nagawa. I think it's 1990s or 1980s. Pero as in, wala pa. Okay. So, bigla na lang siyang sumulpot. Okay, bigla na lang sumikat. I don't know what happened. Hindi ko pa nalaman kung ano yung history ng Python na. So, any other question or clarification so far? And yeah, kung may gusto kayong i-develop sa Android naman, I think Quasar is one of the best language right now. Quasar B. So, aralin nyo to sa YouTube. Ang maganda kasi dito, ang pinaka-advantage ng Quasar na nakikita ko na wala sa iba. Okay, though wala pa siya sa Pilipinas. I think wala pang nag-hire ng may ganitong language. Is you only need one language, or one coding. One coding is equal to all platforms. Yan yung pinaka-advantage niya. So, ito na lang i-share ko sa inyo sa Android Studio. For Android Studio lang, di ba? Android application. Kailangan mo pang gumamit ng ibang platform para makagawa ka ng application sa Apple or yung mga Apple, basta mga yon. Okay, base sila ng platform. And mahirap mag transfer ng from code to code para lang mapagana mo siya sa Apple. But in this Quasar, okay, having one coding and then co-compile mo na lang siya. Yun yung term. Co-compile mo siya into a website, pwede. Into an application, pwede. Into an Android application, pwede. Into a Mac application, pwede. Ganun. So, yun yung pinakamaganda sa Quasar.
Paano niya natatranslate sa sir, sa ibang coding language yung iisa lang?
Mano-mano. Okay? Swerte mo na lang kasi meron ding mga iba na ano ba yung gamit ko? Meron akong gamit dati. There are websites before that I have found wherein you can just simply copy your code and then paste it right there. And then click mo lang yung parang convert to this language to language. Gumagana naman. And then you just need to fix some. Okay, may mga konting flaws pa rin pero na-convert na mostly. Okay, pero sa iba, okay, lalo na yung mga bagong language ngayon, wala. Okay, there is no direct conversion. So mano-mano, isa-isa. Mahihirapan ka talaga. Okay, but in here, isa lang yung code mo and then once you, kasi diba kapag nag-compile tayo, like for example in Visual Studio, once we compile that one, application na siya kagad. Pero meron pa siyang ibang way ng compiling that like you can compile that one as a Android application or as a website or as something like that. So, ayun, for the Quasar. So right now, if you guys are wondering what I'm trying to study right now, so Quasar, kakarinig ko lang, hindi ko pa inaaral. Pero I think that's 2 years from now or 3 years from now, ito yung isa sa mga magiging bagong language or bagong platform na gagamitin. Or hindi naman platform, framework rather, or parang tools lang siya. Okay. So you guys can also check about React.js for websites and then React Native for Android application. So aralin nyo rin to, hindi pa to tinuturo sa school. Okay, sinabi ko to kay Sir Tendian, Sir, paano kaya magturo tayo ng bagong language na ito? Na-figure out ko lang, Sir, nalaman ko lang sa YouTube na mas madali siyang gamitin. Okay, so check nyo rin tong mga bago. So, complete learnings na naman yan, mahirapan na naman. Pero, worth it naman. And then, one more thing, kung narinig nyo na, so, sulitin ko na habang item natin. So, Laravel, pwede pa rin. Kapag, if you guys are into, ito na advice ko, if you guys are into governments, governments, ito yung aralin nyo for website. Dito kasi sila nag-stick sa Laravel. They didn't move to different language anymore. Okay, so ito, din to, I think, parang Java-based din to, pero hindi ko pa chine-check. So, yeah. Laravel. One game. Naku! I'm afraid that you're in a wrong path, Mr. Jean Alexis. If you're into a game, you should have get ComSci. Kasi kapag computer engineering, so yes, we develop softwares like websites, some basic applications, and then some Android applications. But we're not really into gaming. Though pwede pa rin naman, meron yung mga ibang form like amaze na kami dati. Gumawa sila ng stickman na pwede nang mapagalaw. Okay, so yeah, okay din naman yun. Gumamit sila ng Android Studio, though medyo mahaba-haba. And kapag sa game naman, I think Unity yung gamit ko for Gwen. Yeah, Unity. So marami naman ng mga existing na template sa Unity. Check mo rin to kung gusto mong gumawa ng mga games, lalo na sa mga Android games. So yeah, Unity is one of the platforms that you can use. Okay. So ito ang gamit nila dito is C or C++ yata, or C#, basta C, ano maalala. So madami rin akong kinalikot dati. Pero hindi kasi ito naturo din. So hopefully magkaroon tayo ng another subject wherein we can have this kind of expertise. So I'm not just sure if in ComSci or in IT they are teaching Unity, but in computer engineering, I think wala pang Unity for this one. So yeah, I think yun lang yung mga masishare ko sa inyo sa ngayon. So any other concerns or clarifications? You're welcome. Okay. Try mo rin mag-hardware. Kasi yun yung advantage pala natin sa iba. Okay. So we do have the, ang tawag dito, yung, though hindi na kasi siya masyadong ginagamit eh. Raspberry Pi na nga dapat tayo ngayon. So yeah, you can use the Arduino. Yung, ano pa ba, 555 mega. Mga ganun. So yeah. Yan. Okay, so if you guys don't have a question or clarification anymore, then I guess that's it. And you guys may now go. And thank you guys for coming. And then keep safe.
Thank you, sir.
Thank you too.
Thank you, sir.
Thank you too.